is Robert Neville. I'm a survivor living in New York City. I am broadcasting on all AM frequencies. I will be at the South Street Seaport every day at midday when the sun is highest in the sky. If you are out there, if anyone is out there, I can provide food. I can provide shelter. I can provide security. If there's anybody out there, anybody, please.
Urgent post, need to review COVID-19 inspection method. Today is October 19th, 2020 in the Christian era. Coronavirus, CoV, is known as one of the causative viruses of human nasal colds. Until recently, there was no virus that caused the disease that causes severe respiratory failure symptoms in humans. Therefore, research in the medical field was limited. Rather, no one was studying colds. It is thought that the coronavirus infects humans and mutations occur repeatedly at any time in a 10,000-year history of humankind. In addition, it is considered that the coronavirus has been transmitted from animal to human and heterogeneously transmitted from animal, and mutations have occurred repeatedly at any time in the history of human beings over 10,000 years. A vast amount of viral genome sequences are being reported by researchers around the world at an alarming rate. Almost infinitely many. In other words, it is infinite in terms of probability theory considering the number and deletion of the base sequence of the gene. If you keep looking for a new coronavirus, it will never end. The reference sequence used in the literature is a sequence with a length of 29,903 bases initially reported in China, which is registered with the accession number NC045512 in B and EPIL 402,125 in G said. The genome of the new coronavirus is composed of approximately 29,903 bases. There are some individual differences between viruses. The number 29,903 is a paper by Watt et al., published in the journal Nature in February 2020. A new coronavirus associated with human respiratory disease in China. https://www.nature.com articles S41,586-020-2008-3 FBCLID equals IWR1V-FQWQ-FRX157MH8YK4X03BCT8VUNNAYMXMGLXYDWZWLPV4XIMPhi. From 30 kilobits. At the end of the genome, there is a leader sequence consisting of about 70 bases, and the RNA polymerase, ORF1A, 1B, S, E, M, and N genes are located downstream of the leader sequence. Non-structural protein genes, ORF1A, 1B, occupy 20 kilobits of the total, and viral structural proteins, about 10 kilobits, are produced in the region of the S gene, figure 2. Non-structural proteins, NSP proteins, occupy about 2/3 of the viral genome and are known to not only participate in viral replication, but also have various effects on cells. A total of 16 NSP proteins have been produced, and among them, the NSP1 protein is being analyzed. A wide variety of mutant strains have been reported for coronavirus. All mutant strains are S proteins, and ORF1b is a large peptide and encodes multiple proteins. I'm not sure how it works. For gene S, the gene following ORF1b is S, a gene that encodes a spike protein. It has been reported that this protein plays a major role in binding to ACE2 and invading human cells. recombinants are detected at a higher rate in coronavirus infections that have been reported to have point mutations or defects. 31. Two different types. When the same cell is superinfected with coronavirus, a recombinant different from the parent strain is produced. This recombinant is due to homologous recombination, the mechanism of which is the coronavirus genome. It is related to RNA replication. Persistent infection with coronavirus. There are many reports of persistent infections with coronavirus, easily sustained at the cultured cell level. It has been reported that mutant strains with different tissue affinity and pathogenicity appear in infected animals in which infection is established and the properties of both viruses and cells change significantly. This is because, considering the characteristics such as the frequency of virus mutations and common sense, the vaccine is not effective. Worst of all, it was a researcher at the National Institute of Infectious Diseases in Japan who created the virus testing protocol in the early stages. First, there is a need to review this inspection protocol. At present, it is believed that public health agencies and medical institutions around the world are testing all existing coronaviruses that infect humans. However, it is puzzling that very few patients show morbid symptoms in their children. Furthermore, it is extremely mysterious that the close contacts infected from the severely ill patients also showed a positive reaction in the PCR test and were asymptomatic. I would like to establish a system for treatment with a few hours of infusion only for outpatients without being hospitalized or isolated at a medical institution. Please let me know as soon as possible if you have any good measures. If anyone can speak English, if anyone can speak it, call it to the US Department of Defense, the Armed Forces Security Agency OFSA, the National Security Agency NSA, and the Centers for Disease Control and Prevention CDC. http://www.nsa.gov. Worst of all, Japan is trying to spread the virus even further. Japan is trying to develop a technology to further spread the infection. Just exhale to determine if you are infected with the new coronavirus. Such a surprising inspection method has been developed. This is a joint research between Tohoku University and Shimadu Corporation, a major precision equipment company, and we expect that it will be less burdensome and more advantageous than PCR testing. On the afternoon of October 16th, President Hideo Ono of Tohoku University and President Teru Isaweta of Shimadu Corporation made a joint presentation. The newly developed test method can determine whether or not you are infected with the new coronavirus by utilizing the latest technology that analyzes viruses and biotransforms contained in your breath. Specifically, first breathe into a dedicated device for about 5 to 10 minutes to collect the water contained in the breath. Next, viruses, proteins, metabolites, etc. are detected from the water. By applying the detected substance to an analyzer, it is possible to determine whether or not it is infected with the new coronavirus after about 1 hour. Compared to PCR tests that collect samples from the nose or mouth, or use saliva as a sample, the test can be performed simply by exhaling, which is less burdensome and more accurate. Tohoku University and Shimadu Corporation are planning to proceed with clinical research and aim for practical application in about a year. First of all, I want the factories and research institutes of this Japanese company to bomb. There's no doubt that this test method will increase the number of positive individuals exponentially. There is no clear answer as to how many types of coronaviruses infect humans. However, 7 types have been identified. Generally speaking, humans are considered to be constantly infected with multiple viruses throughout the year. In other words, it is considered that the coronavirus is also included in it. Many are considered to be non-severe pathogenic. However, once infected, it is unknown how long the incubation period is. In addition, it is not known to what extent the disease will develop after infection. This is because if it hides in long-lived cells such as nerve cells, it cannot be detected by PCR. SARS-CoV is used not only for humans but also for monkeys, cats, ferrets, mice, rats, etc. In fact, the high pathogenicity of SARS-CoV is thought to be largely influenced by virus-induced host reactions rather than direct cell damage associated with virus growth. In other words, it becomes a phenomenon like an autoimmune disease. It is speculated that it is probably because the mutations occur so frequently in the body that the immune system causes some abnormality in distinguishing between self and non-self, causing an abnormal reaction. Large amounts of cytokines are produced, similar to the strong inflammatory response of cytokines. Storm, and as a result, it may be the result of inducing an abnormally strong inflammatory reaction of the host. Available. The molecular basis of the strong pathogenicity of SARS-CoV has not yet been elucidated, but cytokines. There may be viral proteins that are resistant to. From here on, it will be a little difficult because it will be a molecular biology story, but I will explain it briefly so that the general public can understand it as much as possible. The genome size of coronavirus is about 26 to 32 kilobits, which is the largest of RNA-viruses. Coronavirus RNA encodes 6 proteins. Pages 1a, spike glycoprotein, envelope, membrane glycoprotein, nucleocapsid protein. The coronaviruses 229E and NL63 are classified into the alpha coronavirus genus, and HCO1, OC43, SARS-CoV, and MERS-CoV are classified into the beta coronavirus genus. Among these, SARS-CoV and MERS-CoV cause severe lung disease. It causes, but the other 4 are only cold. Both have a positive strand, messenger sense, single-strand RNA as their genome. In contrast, the influenza virus has a negative strand, single-stranded RNA genome. Therefore, when SARS-CoV-2 is phylogenetically compared with the genomic sequences of 6 types of human coronavirus, SARS-CoV-2 is closely related to the beta coronavirus genus SARS-CoV among coronaviruses. It turned out the homology between SARS-CoV-2 and SARS-CoV is 79.6% in terms of the entire genome. It's not very similar. A domain that binds to a receptor in an adsorbed protein, abbreviated as RBD. It has even been found that 6 distant amino acids in that domain are the points of contact with the receptor. Computer prediction of the 3-dimensional structure of the adsorbed protein of human SARS-CoV-2 reveals that it does not seem to be the optimal structure for binding. Another unique mutation has been found in the S gene of human SARS-CoV-2, which is not found in human SARS-CoV, pangolin SARS-CoV-2, or bat rate 13. It is an amino acid sequence involved in the cleavage of adsorbed proteins. The putative cleavage site of the adsorbed protein of human SARS-CoV-2 is mutated by inserting 4 amino acids before the basic amino acid arginine R, resulting in a PRR sequence. That is, prolin P precedes, followed by 3 RS. The insertion of P causes the protein to bend, followed by a strongly positively charged state. Next to the cleavage site, serine S. threonine T is also located, and O-type sugar chains are bound to these, which can also be mucin mus protein-like. We have seen that the S gene of the spike protein of human SARS-CoV-2 has mutations in its RBD site and cleavage site. However, it is known that its structure changes only when it binds to an antibody or when it binds to angiotensin-converting enzyme ACE2 on the cell surface, which is a cell receptor. What kind of physical and chemical factors are involved in the binding based on this specific structural change is the key to vaccine development, and is thought to be deeply related to the pathological onset. However, it is not known at this time what is causing it. The 5 end of about 20 kilobits of the coronavirus genomic RNA-1 consists of 2 ORFs, 1A and 1B encode 802. Between these ORFs, there is a region with a complex cubic structure called cytoknot (PN). In molecular biology terms, deletion is the loss of part of the DNA sequence. An ORF is the open reading frame, the region that is expected to work baited into a protein in the gene sequence. Become. Of the 7 coronaviruses that infect humans, ILB. Gasso and colleagues at the National Institutes of Health (NI) are highly pathogenic, SARS-CoV, SARS-CoV-2, and MERS-CoV. We conducted a study comparing the genomes of the other 4 coronaviruses with low levels, and found different characteristics between them. Proceedings of the National Academy of Sciences of the United States of America was published in the electronic version on June 10, 2020. Coronavirus RNA encodes 6 proteins. Pages 1A, Pages 1A, spike glycoprotein, envelope, membrane glycoprotein, nucleocapsid protein. We searched for sequences that affect the difference in pathogenicity. As a result, 11 regions of the base sequence that can predict the highly pathogenic coronavirus were identified. The proteins encoded by these regions were pages 1A peptides NSP3, NSP4, NSP14, spike glycoproteins, membrane glycoproteins, and nucleocapsid proteins. Nucleotide sequence insertions and deletions were found in 4 of the 11 regions. Of these, 3 were localized to the nucleocapsid protein, and 1 was localized to the spike protein. Insertion, deletion, and substitution of the nucleocapsid protein of the highly lethal coronavirus are caused by nuclear localization signals, 2 monotype nuclear localization signals, and 1 binotype nuclear localization signal and extranuclear. It was concentrated on the export signal. Next, spike proteins and diagnostic features were examined. SARS-CoV-2 invades host cells via ACE2, and its affinity for this receptor has been reported to be 10 to 20-fold higher than SARS-CoV. The spike protein is composed of multiple domains, in which there are 2 heptid repeats, 7 base repeat sequences, which play an essential role in infection. The fusion peptide of the spike protein is located upstream of the first heptid repeat and has an helical structure. The author's analysis found that the 3 highly lethal viruses inserted 4 amino acids in the binding region between the fusion peptide and heptid repeat 1. However, this mutation was not found in the low-mortality coronavirus. From these results, the authors found that the nuclear localization signal of the nucleocapsid protein was associated with the strength of coronavirus pathogenicity, and that SARS-CoV-2 and MERS-CoV had separate base sequences to the spike protein. We conclude that the insertion is involved in the infectivity of the virus and host cells to fuse. They also say that these studies may help identify coronaviruses that infect animals that are likely to infect humans in the future. If you're interested, Please confirm the sequence position at the target genomic region of the current PCR test once again. The original title is Genomic Determinants of Pathogenicity in SARS-CoV-2 and Other Human Coronaviruses, and an overview can be found on the NIS magazine website. Now, the number of newly infected people is increasing at the planetary level. What is humanity looking for? Explained it. The genome of the new coronavirus is composed of approximately 29,903 bases. The reason for adding "about" is that there are some individual differences between viruses. The number 29,903 is a paper by Watt et al., published in the journal Nature in February 2020. A new coronavirus associated with human respiratory disease in China. https://www.nature.com articles S41,586-020-2008-3 FBCLID equals IWOR1VFQW2FRX71578YK4X03BCTAVUNNAYMXMGLXYDWZWLPV4XIV. 2. From 30 kilobits. There is a leader sequence consisting of about 70 bases at the end of the genome, 500 downstream of it. It exists in the order of polymerase, ORF1A, 1B, S, E, M, N genes. Non-structural protein gene, ORF1A, 1B, occupies 2, 3, 20 kilobits of the whole, and viral structural protein, about 10 kilobits, is under the S gene. Made from the flow area, FIG.2. Non-structural proteins, NSP proteins, occupy about 2/3 of the viral genome and are known to not only participate in viral replication, but also have various effects on cells. A total of 16 NSP proteins have been produced, and among them, the NSP1 protein is being analyzed. A wide variety of mutant strains have been reported for coronavirus, and all mutant strains are S proteins. ORF1B is a large peptide that encodes multiple mature proteins. I'm not sure how it works. Gene S. The gene following ORF1B is the gene that encodes the S spike protein. It has been reported that this protein plays a major role in binding to ACE2 and invading human cells. As a characteristic of coronavirus, recombinants are detected at a higher rate in coronavirus infections that have been reported to have point mutations or defects. When two different coronaviruses co-infect the same cell, a recombinant different from the parent strain is produced. This recombinant is homologous recombination, and its mechanism is related to the replication of coronavirus genomic RNA. Persistent infection with coronavirus. There are many reports of persistent infection with coronavirus. Persistent infection is easily established at the cultured cell level, and it has been reported that mutant strains having different tissue affinity and pathogenicity appear in infected animals in which the properties of both viruses and cells change significantly. In October 2020, a study by the National Institutes of Health (NIH) identified 11 regions of the base sequence that could predict highly pathogenic coronavirus. The proteins encoded by these regions were pages 1A peptides NSP3, NSP4, NSP14, spike glycoproteins, membrane glycoproteins, and nucleocapsid-ring proteins. Nucleotide sequence insertions and deletions were found in 4 of the 11 regions. Of these, 3 were localized to the nucleocapsid protein, and 1 was localized to the spike protein. If the pathogen can be detected by hybridization with a probe that targets a part strongly related to this pathogenicity, the mortality rate will increase. but the number of newly infected persons will decrease. At the planetary level, we need your help to control the spread of the virus. The characteristics of this infection are unknown to potential mild individuals in official statistics. In other words, although there are a huge number of mildly ill people, they are unable to receive treatment, which is a cause of the spread of infection. One of the reasons is social isolation measures. To improve this, it is necessary to start intravenous administration at an early stage of the therapeutic drug all at once. In October 2020, the World Health Organization (WHO) announced that WHO will take the lead in international treatment of new coronaviruses for 4 drugs, including the antiviral drug remdesivir, which has been specially approved in Japan for the treatment of new coronaviruses. In a clinical trial, the results of a tentative study were announced that there was little or no effect on hospitalized patients. However, if the existing therapeutic agents such as nucleic acid analogues, remdesivir, and renopolymerase inhibitors avigan, chemostad mesylate, nimostat, and ivermectin are started intravenously at an early stage, the virus will grow. There is a possibility to stop. If secondary infection is suspected, it is necessary to administer a combination of antibiotics. We urgently request the dispatch of the Army, Navy, and Air Force on a global scale. Without such a treatment policy, not only will the number of patients who become severely ill increase, but also the social structure will be such that mildly ill patients suffer from persistent chronic infections. It's your courage and a single complaint call to stop it. Contact information is provided below. COVID-19 is an emerging, rapidly evolving situation. Operation Warp Speed, https www.defense.gov contact. Get the latest public health information from CDC, https www.coronavirus.gov. Get the latest research from NI, https www.nih.gov coronavirus. Find NB SARS-CoV-2 literature, sequence, and clinical content, https www.nb.nlm.nih.gov SARS-CoV-2. The New Coronavirus Pathogen Detection Manual 2019 CoV has been published on the website of the headquarters in order to widely provide information on the developed test method to other than the local health research institute. When an applicant wants to get pathogen for research, if you applicant belong to the institution outside Japan, please use them to need to format https www.need.go.jp Need images biosafe bunyo y aptx15.docs for an application and send to Need. National Institute of Biomedical Innovation, Health and Nutrition about the start of provision of cell lines that can be used to isolate the new coronavirus. URL https www.nibion.go.jp Information Nibio 2020 02006237 HTML About pathogen distribution procedure. Please refer to the following article on the National Institute of Infectious Diseases website. Procedures for pathogen distribution. https www.need.go.jp Need Your Lab 481 Biosafe 7100-bunyo-shogai17.html Researcher in charge of pathogen distribution, Virus Department 1 Director Sayo. Phone, +81 3-5285-1111. Extension 2502. Clerical Staff. Research Support Section, Coordination Division, General Affairs Department. Phone, plus 81 3-5285-1111 extension 2040,2052 email info@nih.go.jp Imperial Household NC Telepath Psychokinesis Crisis Management Center Life Safety Division located at the Imperial Palace Telepath Psychokinesis Countermeasure R&D Strategy Center Telepath Psychokinesis Central Intelligence Agency Contact http satorari.work emergency contact https bit.ly2high77w The Prime Minister's Office is also accepting comments and requests regarding suicide. The Prime Minister's Office website, comments and opinions, Japanese only, https www.kantai.go.jp jpican.html Kanagawa Administrative Evaluation Office, Ministry of Internal Affairs and Communications Administrative Complaints, +81 570 090 110